Now that you've had a couple lessons about solving systems of equations, I want to review the three methods and talk about not only the three methods, but also then how do you know which method to use? What strategies do we want to use to determine do we want to graph, use substitution, or the elimination addition method? Keep in mind, all these methods will result in the same answer. So I want to give you some strategies to choosing between graphing, substitution, and elimination addition methods. Let's talk first about the graphing method. Here are some advantages or when to use that method. First of all, the equations are written in slope-intercept form. So if the equations are written in y equals 2x, y equals 3x minus 1, those are easy to graph. You can easily write them in, now that they're written in slope-intercept form, you can graph them. You can use your graphing calculator to find the intersecting point. So that is the easiest method when they're already in slope-intercept form. If the equations can be written in a slope-intercept form, so if the equation, maybe one is y equals 5x, but the other one is 2x plus y equals 4. Well, that equation it takes one step to move the 2x over to the other side. Get that in slope-intercept form. Use your calculator and graph and find the intersecting point. So you need to look for slope-intercept form or rearranging the equation into slope-intercept form. Use your graphing calculator, and in that case, graphing is an easy way to solve those. But not all equations are conducive to graphing. So let's talk about substitution. When both equations are written as x equals or y equals, well, let's look at this one. You might say, well, they're both in slope-intercept form, and they are. So graphing might be the best, but substitution is also simple, because if you recall, if y equals 4x and y equals negative x plus 15, then it is quite easy to write as substitution. We can say that 4x equals negative x plus 15. So that's where the substitution was, and that's not a very hard process. Probably graphing, but substitution. This equation is, neither of these are in slope-intercept. So graphing might not be the easiest, but when one equation is written as an x equal or a y equal, that's a sign that maybe substitution might be the best. If you know that x equals 1 minus 2y, then this 1 minus 2y can go right in there for the x. And that might be the easiest way then to solve that one. So you have to look for the cues of how to start those problems and the easiest way to maneuver the equations. Let's talk about the elimination addition method. When to use that, what's the advantages? Well, when the x terms and y terms are lined up vertically. This example, they're already lined up. We have an additive inverse. Simple process to add your x's, eliminate the y's, add your constants. This one could be rearranged to be into slope-intercept form, but much more work. Or when all the terms have a coefficient. So if you look, the four terms here, 5x, 2y, 7x, negative 2y. If they all have coefficients, it is always easier to use the elimination method. If you were to solve for y in either of these to do graphing or substitution, or to solve for x in substitution, you would get a number of fractions, making the process very complicated. So again, when the x terms and y terms are lined up, or when all of them have a coefficient. So let's do some comparisons here, and let's choose the best method. First one, y equals negative 3x, y equals 2x minus 10. Well, these are both slope-intercept form. Graphing, good choice. Another good choice, substitution. Again, let's review the substitution. You're going to take y equals negative 3x, because that is y, and 2x minus 10, they're equal. Okay, so there's the substitution, graphing. Put it on your calculator, graph, see the intersecting point. For this system of equations, they all have coefficients on the variables, very nicely set up here with an additive inverse right here. I would recommend elimination addition on this one, because you're going to add those, and the additive inverse will allow the y's to be eliminated when you add. This one is a bit more interesting. You have a couple options. The first equation is in slope-intercept form, but the second equation is not. Substitution would probably be a good method to use here, because you could take this 2x minus 3 and fill it right in there for that y and substitute it in. Another method would be to solve for y. This one's in slope-intercept, that one's in slope-intercept. You could do that, and if you did that, then you could graph. So graphing is also an option for that one. So what I'm trying to point out is you've got to look at the equations that you're given, think about how the process goes, and then knowing the process will help you decide which method to use and make the math as easy as it can be.